Hello, my precious friends. I really hope that you are doing great. Welcome to today's class. It is our first lesson on the 8th topic of Form 4, which is called X-rays. As usual, let me commence by giving the quote of the day, which states that success only comes to those who dare to attempt. We shall discuss that quote at the end of our class today. So let me give you a brief history about the discovery of X-rays. So X-rays were first discovered accidentally by a German physicist by the name Wilhelm Röntgen, who was conducting research on cathode rays. Then he came across some certain rays which were unique or whose nature was not known. Therefore, X-rays owe their name due to the fact that at their time of discovery, their nature was not known. The same way we say in mathematics, let a certain quantity be X. So Röntgen also said, let these particular types of rays be called X. Hence the name X-rays, because initially he did not understand their nature. So X-rays are simply electromagnetic waves. So remember, under Form 2 work, under a topic called Waves 1, we did discuss the types of waves, whereby we said that electromagnetic waves are those that do not need any material medium for transmission. For example, they don't need material medium such as air in order for them to be transmitted. So X-rays are simply electromagnetic waves with very high frequencies and very short wavelength. So let's look at how we produce X-rays in X-ray tubes. So this is what we are calling an X-ray tube. Of course, it has several features. We have a metal target, which we are calling the tungsten. We have the focusing cathode, of course, whose role is to produce the cathode rays. Then, of course, we have the cooling fins. We have the copper anode. We also have the heater circuit. So we shall look at the function of each and every part. So the production of X-rays are usually produced in X-ray tubes, as shown in this particular diagram. So X-rays are produced in X-ray tubes when fast-moving electrons are suddenly stopped by a metal target or by metal targets. So you can see in this particular case we have a step-up transformer which is stepping up our voltage. So that stepped up voltage is coming into this particular cathode, of course, through the heater circuit. So the heater circuit is going to hit this particular element. Of course, when the element is heated, then of course you can see the element is connected with the cathode. Then we know that the cathodes are usually negatively charged. So the filament is going to hit the cathode such that the electrons within the cathode are going to get excited or to gain some kinetic energy. Hence, they'll be free to move. So because of repulsion, because they're being repelled by this particular cathode, which is negatively charged, because remember, like charges will always repel each other. So the electrons are going to be repelled, hence they are going to form what we are calling an electron beam, or simply a cathode rays. So that beam of electron, it will move in such a way that it is getting accelerated, because remember we have the copper anode. Remember the anode is usually positively charged. So the positive charges are going to attract the negatively charged electrons, or simply the electron beam, of course, which has electrons which are negatively charged. So because unlike charges will always attract each other, so the copper anode, which is of course positively charged, so it is going to attract this particular beam of electron, hence causing them to accelerate or to move at a very high velocity. So when they accelerate, they are going to hit what we are calling a metal target. In this case, we are using the tungsten, or sometimes we can also use a metal which is called molybdenum. So when this particular stream of cathode rays, or when electron beam hits this particular tungsten or the metal target, what you are going to obtain on the other side will simply be a stream of what we are calling the X-rays. So let's look at how X-ray tube works. So the current flows through the filament. Of course, we have the heater circuit here, which is supplying us with the current through this particular filament. So the filament is going to get heated, because remember, the filament is going to convert the electrical energy into heat energy, just like in the same way that you use the heating coils. The heating coils are going to convert the electrical energy into heat energy. That is why you are able to boil water using the heater or simply the heating element. So in the same case, this particular element, when it gains the electrical energy or simply the current, the electrical energy will be converted to heat energy, which is going to hit this particular cathode, hence producing the electrons or a stream of electron beam. So the current flows through the filament. So of course the filament will convert the electrical energy into heat energy, which then becomes hot, and the electrons are then emitted by the process of thermionic emission. So simply, thermionic emission is the process of producing electrons or ions due to heat. So that is how the heater element is going to help us. So the current, when the current flows through the heating filament becomes hot, and it also hits our cathode. So of course the cathode is going to produce electrons by the process called thermionic emission. Then the emitted electrons are then accelerated towards the target, which is usually connected on the anode. So you can see we have an anode here where we are connecting the copper, and also we are also connecting our tungsten metal. So they are connected on the cathode to help us to, that is on the anode, so as to help us to accelerate the electrons. Remember, the anode is positively charged and the electron beam is negatively charged. Therefore, unlike charges are going to attract each other. So the positively charged copper, or simply the tungsten, which is connected on the anode, so because the anode is positively charged, it will accelerate this particular electron beam, which is negatively charged. So the emitted electrons are then accelerated towards the target, or which is simply the anode, by the high potential difference between the anode and the cathode. Yeah, there is usually a high potential difference between this particular anode and of course the cathode here, so as to create a very large potential difference that is going to attract or simply to accelerate the electron beam, so that we find X-rays which have better qualities and quantity. So the emitted electrons are then accelerated towards the target, or simply the anode, by the high potential difference between the anode and the cathode. Then when the electrons hit the metal target, so you can see this is a stream of electrons that have been produced from the cathode rays, that is on the cathode as a result of hitting that particular cathode. So it is being accelerated towards the metal target. When it hits the metal target, you are going to obtain a stream of X-rays. So when the electrons hit the metal target, which is usually either tungsten or molybdenum, so we usually choose a metal like tungsten or molybdenum because of its high melting point. That is, remember, some of the heat is going to be, some of the energy possessed by the electron beam is going to be converted to heat. So because tungsten has a high melting point, so that means it has the ability to remain without getting into the molten state, or without melting even at very high temperature. So the electron beam hits the metal target or the tungsten, or sometimes we can use molybdenum, so they are stopped, and then the X-rays are produced. So you can see these are a stream of X-rays. Then we are saying that only 0.5% of the kinetic energy of the electrons, so the kinetic energy possessed by these particular electrons, only 0.5% of the kinetic energy of the electrons is converted to X-rays. So that means the rest of the percentage will be converted into heat. So the rest is converted to heat. That is why you need a metal of very high melting point, such as tungsten, so that it does not melt up in the process of producing X-rays. Next, we look at how various features enhance the working of an X-ray tube, and we are saying that in the X-ray tube, the cathode is concave shaped so as to focus the electrons onto the metal target, which is usually either tungsten or molybdenum. So remember, you can also say that the cathode is concave shaped so as to focus the electron beam onto the metal target. So you can see this is what we are calling our cathode. You can see it is somehow curved. So this is what we are calling the concave shape. So it is concave shaped so as to focus this particular electron beam, or this particular stream of cathode rays, to focus them onto our metal target. So remember, when the beam of cathode rays, or when the beam of when we have an electron beam hitting a metal target, we are going to obtain X-rays on the other side. So the main purpose of having a concave shaped cathode is simply to concentrate or to focus the beam of electron onto our metal target, so that most of the electrons within the electron beam are actually converted to X-rays. Then the anode is made up of a good conductor of heat, such as copper. This is to ensure that the heat generated when electron hits the target is quickly conducted away from the target. Remember, copper is a very good conductor of heat, and we said that when this particular electron beam hits our metal target, only 0.5% of its kinetic energy is converted to X-rays. So that simply means the remaining percentage, which is about 99.5% of the kinetic energy possessed by the electron beam, is going to be converted to heat. So remember, that's a lot of heat which can cause the tungsten to melt up. That is why we need to conduct that heat away immediately it is being produced when this particular electron beam hits our metal target. So we are saying that the tungsten is usually a material of very high melting point. That is why it doesn't melt away easily, and at the same time we also want to reduce that melting effect by conducting the heat produced away. So that is why we connect. We have the copper anode, which are very good conductors of heat. So immediately that heat will be produced here, it will be conducted away as the 0.5% of the energy is converted to X-rays. So it is important to conduct away that heat to prevent our tungsten getting to a point where it is melting away. So the copper anode, they are very good for conducting away the produced heat. You can also see that we have an oiling system. We have oil getting in, then of course at this particular point it is getting away. So the oil is also helping us to conduct away the heat that has been produced by this particular tungsten. So you have the oiling system. So we have cold oil getting in, then it is conducting away. So this is hot oil getting outside. So it is continuously circulated to conduct away the heat that has been produced on the tungsten or our metal target. Then the target is made up of tungsten or simply molybdenum, because tungsten or molybdenum has a high melting point. Therefore, it can withstand the heat generated without melting. Remember, 99.5% of the kinetic energy is converted to heat. So that heat needs to be conducted away. So we need a metal of very high melting point to withstand the heat generated without melting away. Then the cooling in the X-ray tube, it is enhanced through the following. So cooling in X-ray tube is enhanced by 1, the cooling fins outside the tube. So you can see we have the cooling fins which help in conducting away the heat, hence cooling the tungsten. Then we also have the oil circulating through the channels in the copper anode. So the oil also helps us to conduct away the heat, because the oil getting in is usually cold, then the one getting outside is hot, that is carrying away the heat. Then the anode is made up of a good conductor of heat, such as copper, which conducts away the heat produced on the tungsten. Then lastly, we look at how other features enhance the working of this X-ray tube. So we are saying that the tube is highly evacuated. To evacuate is simply to create a vacuum, or simply to drive away any material medium within the tube, such as air. So the tube is highly evacuated so as to prevent electrons from colliding with air particles on their way to the metal target. So you can see we have a vacuum inside here. So we have derived all the material medium, such as air, from this particular tube to prevent this particular electron beam from colliding with air molecules that will lead to loss of kinetic energy, which will lead to production of low quality and low quantity of X-rays, since most of the electrons will not actually hit the tungsten at very high energy or at very high velocity for them to be converted to X-rays. So we evacuate the tube, or simply create a vacuum to prevent the collision of the electron beam, or simply these cathode rays, from colliding with the air molecules, leading to loss of kinetic energy. So the tube is highly evacuated so that to prevent the electrons from colliding with air particles on their way to the metal target. Then the air particles can cause the electrons to lose some of their kinetic energy. This would reduce both the quality and quantity of X-rays produced. Then number 6, we are saying that the X-ray tube is surrounded by lead shield. So this particular tube, we usually surround it with a lead shield. The reason is that this is used to absorb any stray X-rays, that is any X-rays that are trying to get out of the tube through undesired routes. Remember, X-rays can destroy even some of your body cells, so they are very dangerous. That is why we need to protect people working within or around that particular X-ray tube from those particular X-rays, because they can be harmful to the human cells. So usually the X-ray tube is usually surrounded by that is what we are calling the lead shield, so to absorb any stream of X-rays that could be trying to get out of the X-ray tube through undesired ways. So the X-ray tube is surrounded by lead shield. This helps to absorb any stray X-rays. Then we look at the energy changes occurring in the X-ray tube during the production of X-rays. So of course we have the step-up transformer, which is supplying us with that is the current or simply electricity. So the heater circuit is supplying us with electrical energy. So the first step is electrical energy. Then of course when the electrical energy gets to the filament is going to heat up, hence converting the electrical energy into heat energy. So that electrical energy, the way that is the cooking coils or the heating coils work, when they get heated, they have materials of very high electrical resistance, which is going to resist that electrical energy, hence converting it to heat energy. So the heat energy, of course, is used to heat our cathode, which is going to produce the excited electrons or electrons with a kinetic energy. So because of the attraction, because this is the anode is going to attract these particular electrons, hence they accelerate. So remember, when the electrons are moving, they possess what we call kinetic energy. So from heat energy, they are going to have kinetic energy. Then of course, from kinetic energy, these electrons have kinetic energy. That is why they are being accelerated to hit the metal target. Once they hit the metal target, we are going to have 99.5% of the energy getting converted to heat energy. Then of course the 0.5% of the kinetic energy will be converted into a stream of X-rays. So we have heat energy plus X-rays. So this is the energy changes that take place in a cathode ray tube. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that success only comes to those who dare to attempt. So the quote is encouraging us to be bold enough to take risks in life, because that is the only way we can explore the limits of our potential and achieve our dreams. Most of us fail to take the first step towards achieving our dreams just because we are afraid of what could go wrong or what other people will say about us when we fail. Recall that you will never fulfill your purpose in this life without stepping outside of your comfort zone and taking action towards achieving your dreams. And lastly, remember that only those who will risk going too far can possibly find out how far one can actually go. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you will get notified. Until next time, this is Kind Tuition Academy. Thank you very much.